Hi everyone, welcome to machines class. I hope you found the first internal, the practice internal part 1 easy. Okay, so today we're going to go over practice internal building 1. Again, it's part 1. Alright, so we're going to finish the part 1 from each practice internal first, and then we're going to go on to part 2, which is the difficult part, the excellence one. Okay, so hopefully by reading all this, okay, you should be able to find some points. That this one is -7, right? This one 14, okay, right? That one 24, 13, and this value as well. Right, according to the question, you have to come up with piecewise function involving at least 3 different type of functions. Okay, so sketch the graph, give the equation, describe the feature, and the transformation. Okay, then let's have a look at this one. Right, what do you think? So, first, what was the tip that I gave you last lesson? Do you remember? Always start the very first, make the very first graph that's starting from 0 and onwards, make it a trig function. Okay? Then that's going to be, rest will be pretty easy. The reason why we put the first function after 0, trig function, is that then we don't have any horizontal translation that we need to think about. So that's my tip for you. Okay, saying that I'm going to make this trig function, what about this one? Okay, this can be a parabola by looking at, if I draw like this, right? This can be a parabola. This can be a trig function. But my question is, where does the second graph ends? Is it here? There? Where? Okay, so have a look. From here to there, it's quite smooth, and I can say it's part of the trig graph, but where does it end? Does it end here? Does it continue right all the way up till there? Okay, why not? You need to see the maximum point. The maximum height is not equal, but it's slant. This is the highest peak, and that's the second highest peak. So if the maximum point does not match, then you can immediately say, this is a different part of the graph. So therefore you need to carefully look which whereabout has little tilt in the graph. Did you notice that? Yeah, it's this point. Okay, so there's a little tilt at this point. Okay, what's the other method to find out that this point is the linking point? Okay, first you need to find out the midline of this equation. How would you find where the midline is? Yep, the most important thing is look at your peak, okay, look at the lowest point, and the distance should be right in the middle. Okay, so from 14 go down 1, 2, 3, and from 8 go up by 1, 2, 3, and its midline is at, yep, 11. Okay, so you know where you found where your midline is. Okay, and check from the midline whether the amplitude is equal. Okay, from midline to the peak, midline to the trough. Okay, yes, those two are equal. So the function is continuous till there. Okay, then how can I check whether it's this point or that point? Right, so check this part. I have 1, 2, 3 units. That's a quarter of a circle. 1, 2, 3 units to the another to have another quarter of the circle. 1, 2, 3 to have another quarter of the circle, and it stops there because it holds a different maximum value over there. So that's how I find out that my trig function follows from 0 and stops at 18. Okay, so as I said, since I now know that this is my linking point, this is going to be my graph 1, that's my graph 2, and last one will be this one. What's the equation for the last one? It has to be parabola, isn't it? There's no other function that can be this one, unless if you want to do another trig function, but you can't do that. So this has to be parabola. Then this one can no longer be parabola, but it needs to be a cubic function, and it's going up like this steeply, so it's a positive cubic. Alright, so that's how you define which function you need to use for each one. So this is the very important step, the very first step, but very important step. If you distinguish all that, rest is pretty simple. Okay, so there you go. I just quickly drew the sketch with all the important points that I need to know. Right, my graph 1 will be cubic, and that's going to be POI point, because that's the turning point going up like that. This is the POI as well as the linking point. So since the linking point is already used, I can use any other point on the curve, right? But I'm going to use the exact point that was given from the question, which was -7. Okay, there you go. I quickly draw the sketch. This is my POI, where at the same time it was the linking point, and that was a definite point that was given from the question. Remember, when you were sketching it, you're not scaling it, but you just you need to label all the important points. The graph needs to cross the y-axis and also the x-axis with the values. Okay, so finding the equation, there you go, that's my general equation. Right, what's my B and C? B and C's are my POI, that's correct. So change sign for POI, B, but +0 or -0, it's the same. And you're keeping the sign for 14. There you go. Right? And since I already used the linking point, I can pick any other point that's definite, which is -7, 0. So -7 in the x, y 0. Okay, I need to find this whatever inside the bracket first. Times by a, send 14 away, and there you go. 14 divided by -343 should be that one. Okay, always put a as a fraction, because fraction is the most accurate number. Okay, there you go. What's after that? Yes, I found out the equation, the sketch, right? I need to do features. But remember, domain and the range are inside the features, but that's from the question. So domain starts from -7 all the way up to where? 0. Whereas the range, it's down from the lowest point is from 0 all the way up to 14. Okay, so remember, domain is the widest part, -7 to 0, whereas the range is from 0 all the way up to lowest to highest, 0 to 14 of the piecewise function. So there you go. It always needs to be in a square bracket. And people, you should now know this. These two, you can find it out from graphics calculator as well. Point of inflection is where the curvation changes. So this point here, the curvature changes from sad to happy at this point. And also, what symmetry does it hold? Point symmetry. Yep, at this point, if it's rotated, it's going to come back to the graph as it is. So therefore, you should be able to write features like this and the transformation. Okay, remember, always start from the graph of the original function y equals x cubed and explain how it has been changed. Okay, right, so people, this is my answer for graph 1. Remember, these answers are at the back of your book as well, so please note that. Okay, so my next one, the one in black, yep, that's a trig function, which is cosine. Yep, so even though the piecewise function from the equation only showed from there all the way up to 18, but you need to draw at least one full cycle. Okay, since starting from the top, coming down needs to come back to where it started. Okay, so this is one full cycle. Please write, draw arrows, little arrows, to indicate that it's continuous to left and right hand side. Okay, and you need to tell us what each of these points are. Okay, so those 2 points was given from the question. Okay, how could you find out that one? Yep, obviously, since this point is half of that, so it's 12, so half of that is 6. So it's going up by 6, 6, 6, so that needs to be 18. Adding another 6 will be 24, or you could just double 12, because that 12 is half of the entire full cycle. Okay, that's how you need to find it out. And to find out the midpoint, always find the middle value of it. Just go down by some number, up by some number. Okay, and you can find out the midline. Okay, knowing your midline is 11, what's your D? Okay, vertical translation. At this time it's D. Yep, it's 11. D is 11. Right. Since I chose my first equation that's starting from 0 to be my trig function, I would not have any C value. C value is just 0, so you can just ignore my C value. Right, from the midline to the top, from the midline to the bottom. Okay, what is the distance? Yeah, the amplitude is 3. Well done. Okay, what's my B? B is always 360 divided by the period. What is my period? One full cycle. Period is 24. So 360 divided by 24 is 15. Okay, so finding out all those values, I'm just gonna plug it in. Okay, and again, domain and range from the question. Okay, domain was from 0, another to widest part is 18. Okay, and the range, the lowest is 8 all the way up till 14, just like this. Right, and you need to talk about the feature. Remember, cosine, it holds line symmetry. Okay, because if you draw a line in there, if you fold it in half, left hand side and right hand side should be symmetrical. Okay, point of inflection is these 2 points in this one cycle, one period, right? So you need to write these 2 points. Okay, and maximum point as well in the cycle, you can see 2 of them, minimum this value, right? Okay, this is how you need to write the translation. Always say amplitude has been increased, decreased, or changed from 1 to something, right? The period, how has it been changed from 360? So it has decreased from 360 to 24. Amplitude increase from 1 to 3, and so on. And please remember the unit, okay? If you read the question, it says meters. So instead of writing unit as if you've done in the workbook, now you're going to write meters in the unit. Okay, so that was the answer for the second one. Right, now the very last one. Okay, this is a parabola. Right, people, even though it does not pass the another x-intercept and the y-intercept, yeah, but in the sketch you need to draw the full graph that crosses both x-intercepts and also the y-intercept. Okay, just like this. Right, I am not scaling it. I'm just writing it down, indicating the important point, 1, 2, 3 points. And also this point was the linking point, 18,11. So I just indicated in there. Remember this point? Okay. So in this case, what is my B and C? Yep, this maximum, the turning point, is my B and C. So since I used that one, which other point should I use to find out the A? So have a look at the graph. What is the linking point? In order to find out the A value, it's always best to use the linking point. That the point that links the previous graph and this graph. So 18,11 is a linking point, so you need to use this one to calculate the value for A. Okay, so if you look at the graph, you might be tempted to use this value because this looks quite accurate, right? Or any other value, or even that value, okay? But we never know if this value is like 36.1, right? It wasn't given. So always use the linking point, which will be given, or which you can easily find out. Work it out. Okay? Right, so back to this. So my B and C was this turning point. Always change sign for B and keep the sign for C. Okay, and I used the linking point for my A and B, and I calculated the A value. Okay, so always remember to calculate what's inside the bracket squared and do the algebra. Okay, so here are my features and transformation. I think these two are straightforward now. So have a go. Answers are at the back of your workbook as well, so check it. Okay, so these sort of thing, line symmetry through, that sort of thing, many student misses it, or units. Okay, please check your answer carefully, and I hope part A is straightforward now. Alright, then I'll see you in the next lesson with the part 2. Bye bye.